The Linux world never really stands still. Every single week something changes, something improves, something breaks. And sometimes something controversial happens that sparks debates across the entire open source community. But lately the pace has felt even faster than usual. New kernel security features are arriving. Desktops are becoming smoother and faster. Distributions are adapting quickly, and even major organizations connected to the Linux ecosystem are making decisions that cause strong reactions from users. So today we're diving into some of the biggest Linux news stories right now, including safer kernels, faster desktops, and a surprising controversy surrounding Mozilla and artificial intelligence. All of these developments together show exactly where the Linux ecosystem is heading in the coming years. Let's start with one of the most important foundations of the Linux ecosystem, the Linux kernel itself. The kernel is the core of every Linux distribution, whether you're running Ubuntu, Fedora, Arch Linux, Linux Mint, or Debian. Everything from hardware communication to memory management depends on the kernel working reliably and securely. And in recent months, developers have been focusing heavily on one major goal: making the kernel safer. Security has always been a priority in Linux, but modern threats are becoming more complex. Memory corruption vulnerabilities, privilege escalation exploits, and kernel-level attacks are some of the most serious problems that operating systems can face. To address this, kernel developers have been gradually integrating technologies designed to eliminate entire categories of vulnerabilities rather than just patch individual bugs. One of the most talked about improvements is the ongoing push toward memory safety. Traditional C code, which most of the Linux kernel is written in, gives developers enormous control over memory. But that also means mistakes like buffer overflows or use-after-free bugs can occur. To reduce these risks, developers have started introducing Rust into the Linux kernel. Rust is a programming language designed specifically to eliminate many memory-related vulnerabilities through strict compile time checks. Instead of relying entirely on programmers to manage memory correctly, Rust enforces rules that prevent common errors before the code even runs. This is a huge step forward for long-term kernel security. Now it's important to understand that Rust isn't replacing C inside the kernel overnight. The Linux kernel is one of the largest and most complex software projects ever created. Millions of lines of code already exist, and rewriting everything would be unrealistic. Instead, developers are gradually introducing Rust for new components, especially drivers and subsystems where memory safety can provide the most benefit. For example, new drivers written in Rust can reduce the risk of crashes caused by memory errors. Over time, this means fewer vulnerabilities and more stable systems for users running distributions like Fedora, Arch Linux, Debian, and Ubuntu. Many kernel maintainers are excited about the potential of Rust because it adds another layer of protection without fundamentally changing how Linux works. Another major kernel improvement focuses on hardware isolation and security boundaries. Modern CPUs now include features designed to prevent attacks that exploit speculative execution, memory leaks, or privilege escalation. Kernel developers are constantly updating Linux to use these protections more effectively. Technologies like kernel control flow integrity, stack protection improvements, and enhanced address space randomization are being strengthened. These features help ensure that even if attackers manage to find a vulnerability, exploiting it becomes far more difficult. In other words, the kernel becomes resilient against entire classes of attacks, rather than just fixing individual bugs. These improvements benefit every Linux distribution. Whether someone is running Ubuntu on a laptop, Fedora on a workstation, Arch Linux on a custom desktop, or Debian on a server, the underlying kernel security improvements apply to all of them. That's one of the biggest advantages of the open source ecosystem. Improvements made by kernel developers eventually reach millions of users across countless distributions. While kernel security is getting stronger, another major area of improvement in the Linux world is desktop performance. For years, Linux desktops have steadily evolved, but recently we've seen especially rapid progress in performance, responsiveness, and graphical smoothness. Two desktop environments in particular continue to lead the way: GNOME and KDE Plasma. Both projects have been investing heavily in performance optimizations, especially when it comes to modern graphics technologies like Wayland. Wayland is the modern replacement for the aging X11 display server. For decades, X11 has been responsible for handling graphical windows on Linux systems, but its architecture comes from a completely different era of computing. Wayland aims to simplify the graphical stack, reduce latency, and improve security by redesigning how applications interact with the display server. Distributions like Fedora have already adopted Wayland as the default for the GNOME desktop. Ubuntu has also moved toward Wayland as the standard graphical session. Even distributions like Arch Linux and Debian increasingly encourage Wayland usage as support continues to improve. The result is faster desktop responsiveness, smoother animations, and better handling of high refresh rate monitors. Users running GNOME on Fedora or Ubuntu often report that the desktop feels noticeably smoother than it did just a few years ago. KDE Plasma has also been making massive strides in performance. The KDE developers recently introduced major improvements in Plasma 6, which is built on newer versions of the Qt framework and modern graphics libraries. Plasma 6 focuses on improving Wayland support, reducing resource usage, and refining the overall desktop experience. One of the biggest achievements of Plasma 6 is that it manages to deliver powerful customization features without sacrificing speed. Historically, KDE Plasma sometimes had a reputation for being heavy, but modern versions are incredibly efficient. On many systems, Plasma actually uses less memory than some competing desktops. Users running distributions like Arch Linux, Fedora KDE Spin, or KDE Neon are already experiencing these improvements. Plasma feels smoother, animations are more consistent, and Wayland compatibility continues to expand. Another factor contributing to faster Linux desktops is the growing adoption of newer graphics technologies such as Vulkan. Vulkan allows applications to communicate with graphics hardware more efficiently than older APIs like OpenGL. This benefits not only gaming but also desktop rendering and graphical performance. Many modern Linux applications are gradually adopting Vulkan for rendering tasks. Combined with improvements in Mesa graphics drivers, this means smoother performance on both AMD and Intel GPUs. Even users with integrated graphics often notice significant performance improvements compared to older Linux setups. Gaming on Linux is also benefiting from these performance improvements. Valve's Proton compatibility layer continues to make it possible to run many Windows games on Linux with surprisingly good performance. Steam Deck development has accelerated improvements across the entire Linux graphics ecosystem. Because the Steam Deck runs a Linux-based operating system, Valve has been heavily investing in improving drivers, compatibility layers, and gaming performance. These improvements benefit not only Steam Deck users but also desktop Linux gamers running distributions like Arch Linux, Fedora, or Ubuntu. But while many parts of the Linux ecosystem are improving technically, not all recent news has been positive. One controversy that recently sparked heated discussions across the community involves Mozilla and artificial intelligence. Mozilla, the organization behind the Firefox web browser, has historically been seen as one of the most important defenders of the open web. Firefox remains one of the few major browsers not based on Chromium, which makes it essential for maintaining diversity and competition in the browser ecosystem. However, recent decisions related to artificial intelligence have raised concerns among some users and open-source advocates. Mozilla has been exploring AI integrations and experimenting with features that incorporate machine learning models into Firefox and other projects. The controversy began when users discovered that certain AI features could potentially involve sending data to external services or integrating with proprietary AI systems. Many in the Linux and open-source community worry that this could introduce privacy risks or reduce transparency. Critics argue that Firefox has always been valued for its strong privacy protections and open-source philosophy. Integrating AI services that rely on external cloud processing could undermine those principles if not handled carefully. Some community members worry that Mozilla might follow trends seen in other tech companies, where AI features are added quickly without fully considering long-term privacy implications. Others argue that AI tools can be useful if implemented responsibly and transparently. Mozilla has responded by emphasizing that privacy remains a core value and that many AI experiments are optional features. They also highlight ongoing work on local AI models that can run directly on the user's device without sending data to remote servers. Still, the debate highlights a broader issue facing the entire tech industry. Artificial intelligence is becoming integrated into nearly every type of software, but users are increasingly concerned about data privacy, transparency, and control. Linux users, in particular, tend to value software freedom and transparency. That's why controversies like this often spark strong reactions in the community. Many people choose Linux precisely because it offers greater control over their systems compared to proprietary platforms. Another interesting trend in the Linux world involves the growing diversity of programming languages being used in major, open-source projects. While C and C++ remain dominant in many areas, newer languages like Rust, Zig, and Go are becoming increasingly popular. Rust, as we discussed earlier with the kernel, is gaining traction because of its focus on memory safety. But other languages are also gaining attention for their simplicity, performance, and modern design. Sig, for example, is a relatively new programming language that aims to provide low-level control similar to C while improving safety and developer productivity. Some experimental projects are even exploring rewriting parts of traditional Linux infrastructure. Using Zig, these efforts aren't about replacing existing tools overnight. Instead, they reflect a broader trend where developers are experimenting with new approaches to long-standing software challenges. Another big area of Linux development right now is containerization and cloud infrastructure. Linux already dominates the cloud computing world, powering the majority of servers and data centers worldwide. Technologies like Docker and Kubernetes rely heavily on Linux kernel features such as namespace and control groups. These tools allow developers to package applications in containers that can run consistently across different environments. Major cloud providers including Amazon Web Services, Google Cloud, and Microsoft Azure all rely heavily on Linux infrastructure. Even companies historically associated with proprietary software now depend on Linux for their cloud platforms. As cloud computing continues to grow, improvements to Linux container technologies are becoming increasingly important. Developers are working on making containers faster, more secure, and easier to manage at massive scales. Another interesting development is the growing popularity of immutable Linux distributions. Traditional Linux systems allow users to modify system files directly, but immutable distributions take a different approach. In an immutable system, the core operating system is read-only. Updates are applied atomically, meaning the entire system image is replaced with a new version. This approach reduces the risk of system corruption and makes updates more reliable. Examples of immutable Linux distributions include Fedora Silverblue and OpenSUSE MicroOS. These systems are designed to work seamlessly with containerized applications, allowing users to install software in isolated environments without modifying the base system. Many developers believe immutable operating systems could represent the future of Linux desktops and servers. By separating the core system from user applications, updates become safer and easier to manage. Another fascinating area of Linux innovation is hardware support. Linux now runs on an incredible range of devices, from tiny embedded systems to powerful supercomputers. Support for ARM processors has grown dramatically in recent years. ARM-based laptops and servers are becoming more common, and Linux distributions are adapting quickly to support these architectures. Projects like Asahi Linux have even brought Linux support to Apple Silicon Macs, which use ARM-based processors. This demonstrates how adaptable the Linux ecosystem can be when developers collaborate to solve challenging technical problems. Looking ahead, the Linux ecosystem continues to evolve in ways that few people could have predicted decades ago. What started as a hobby project by Linus Torvalds has grown into the foundation of modern computing infrastructure. From smartphones and routers to cloud servers and supercomputers, Linux powers an enormous portion of the digital world. And with ongoing improvements in security, performance, and hardware support, its influence will likely continue to grow. The recent developments we discussed today: safer kernels through memory safety improvements, faster desktops through Wayland and modern graphics technologies, and debates about AI integration in projects like Firefox show that the Linux world remains vibrant and constantly evolving. Open source communities thrive on discussion, experimentation, and sometimes even disagreement. That's part of what makes the Linux ecosystem unique. Instead of a single company controlling everything, thousands of developers collaborate to shape the future of the platform. As new technologies emerge and computing continues to evolve, Linux will likely remain at the center of innovation. Whether it's improving security through Rust in the kernel, refining desktop performance in KDE Plasma and GNOME, or debating the role of artificial intelligence in open-source software, the Linux community continues pushing forward. And if the pace of recent developments is any indication, the coming years will bring even more exciting changes to the world of Linux.